So here we go again. We can identify slope convection from the signature in terms of salinity and temperature. Okay, because if you move very cold and saline water down the slope, you can see the trace or the direct evidence of this flow from measurements of temperature. And this is shown here. So these are some famous measurements of such a slope convection. Here on the left-hand side, it's a vertical profile of temperature. It's actually potential temperature here, but anyway, of temperature cutting across the continental margin. And you can see a vertical ranges from the surface to 3,500 meters. And you can see some shallower parts, 500-meter depth here, the continental shelf. Shelf break, and this is the continental slope. And temperature, you can see the lines. The lines are actually contours. And what contours do is they connect the regions with the same value, with the same temperature. These are isotherms here. Okay, and you can see very, very cold, minus 0.4 degrees Celsius, spreading parallel to the continental slope. And you can see a connection from the shelf to the deep sea. This is the slope convection. It's an advective component between the shallow and the deep region. Salinity, you can also see the structure. You can see this connection of higher salinity water near the shelf bottom and then downward signature of. Okay, and if you see something like this, you already have a guess that it's also associated with the downward transport of dissolved oxygen in the air. This is a mechanism that brings dissolved oxygen in. Okay? So now these Baines and Condy, these authors, they looked at the Antarctic shelves, and they wanted to know where is the water, where does this process take place. And this is illustrated here on the next sketch. They looked at all available observations and temperature and salinity distributions, and they could identify active downslope flows from the Weddell Sea, which is this area here, okay, from the Ross Sea. These are the two key areas, but also here in this area, here in Fritz Bay, in this area, is also a region where these flows have been identified. In addition, they identified passive downslope flows. Passive downslope flows means actually transform flows. No direct connection to the shelf, but a signature at depth. And you can identify these regions here. And if you learn a little bit more about the oceanography of these flows, it's actually a signature of the Coriolis flow. So away from the formation area, these flows are actually deflected to the left or to the west as they move along the continental slope. Okay, so this is the process that we call slope convection.